finally, I've got a piece of wire here.
Yeah.
And I'm going to try to turn this wire into a lime.
Okay.
And I just have, this is all I have here, a little beaker of hot water. I'm going to try to turn this into a lime.
Okay.
All right, here we go. You ready? There's the wire right now. I got my wand here a little. Okay, good. All right, watch. Here we go. Turn wire into a lime. Okay, there we go. There we go. Hold on. All right, hold on. Wait for it. Wait for it. All right. And what does that say?
Lime.
There you go. Look at that. It says lime.
Oh, jeez.
I turned it into a lime. This is called memory wire, and I actually kind of programmed it by heating it up into this shape of a lime. And then you can unbend it, whatever shape you want, and you get it in hot enough water, and it will automatically go right back. And in this case, it gets turned into a lime. Isn't that cool?
What's that, you may be asking? Well, today I'm going to show you the physics behind the magic metal that is nitinol. Nitinol is a metal alloy of nickel and titanium, roughly 50% of each. It exhibits super elasticity and shape memory. It was discovered in the nickel-titanium Naval Ordnance Laboratory by William Buchler and Frederick Wang in 1962, and that is where the name comes from. So how does it actually work, and what gives it these properties? It goes through a martensitic conversion. This is when a material with an austenite crystal structure changes to a martensite crystal structure. During this process, no atomic bonds are broken, but only deformed. The change simply happens because some of the atoms do not move quickly enough when heat or stress is applied. The percentage change is minimal, but when multiplied on such a large level, the results are very much noticeable. At high temperatures, nitinol takes the austenite crystal structure, while at cold, lower temperatures it adopts the martensite crystal structure. It is a metal alloy, so the atoms are very secure, so when it returns from the deformation, as the percentage change was small, and with the atoms being securely fixed from before, the metal can remember where it was, hence its name. The same can be said for its super elasticity. When stress is applied, the material will spring back to its original shape. So how is it produced? There are two methods that can be used: vacuum arc remelting and vacuum induction melting. Vacuum arc remelting is used in high value applications. It improves the quality of the metal significantly. The solidification rate is tightly controlled. The gases which will damage the material in normal processes are taken out. Elements with a high vapor pressure are lowered in concentration. Titanium can only be smelted in a vacuum furnace. Alloy is laid at the bottom of the chamber, and the electrode is brought near it to form an electric field through which the alloy is melted. The water jacket keeps it cool, and the melting rate will be kept at a constant. Vacuum induction melting works in a similar way. It works by creating electrical currents, electromagnetic induction, which heat the metal. Nitinol wire can be used for many different things across a wide field. It's used by orthodontics for the brackets and wires and braces. As it changes shape, you can use it as a golf club insert. Nitinol is also popular in extremely resilient glass frames.
A bunch of scrumpled wire in a dish, but this is no ordinary wire. This is nitinol metal, which remembers a predetermined shape, and you can get back to that shape simply by pouring warmish to gently hot water, I would call this, over the piece, and see what happens. Goodness me. And there has the word, oh, turn it over, hot. That's nicely done. And then you can take it out, cool it down, and scrumple it up again. And for many, many hundreds of times, it will restore itself to HOT for hot.